to announce today with us, we have Andrea Thomaz. Andrea Thomaz is professor at UT Austin. She is also CEO and founder of Diligent Robotics. And we're very excited to have her with us today to chat about both of her efforts. Andrea, welcome to the podcast. Really glad to have you.
Thanks, Pieter. It's great to be here.
So, as I think back of the times we've met in the past, the thing that really stands out to me is, I think it's maybe 5-6 years ago, visiting Georgia Tech. And I remember I walk into your lab and there's this robot called Kieron. And I remember the amazing thing was that actually I got to interact with the robot. There was a demo with interaction. And I got to teach the robot something. And that really stuck with me because, I mean, in reality, usually robots are quite isolated. They're set up in places where people don't go. And then even if you get to go there, you don't actually interact with them. But that's actually a hallmark of your work. You're bringing robots into the world that we can interact with.
That's right. I've been fascinated about this for years. It's really like a passion of mine.
You've pioneered the space, and what I'm really curious about as a first question here is Moxi. So Moxi is a robot, as I understand it, that is in hospitals today. What is Moxi? What is it doing there?
That's right. Yeah. So Moxi is a robot assistant that is working side by side with nurses and frontline staff to do fetching and delivering tasks, which is really general. But if you go to a hospital, a lot of the nurses and clinicians and people that really should be focused on patients and patient care, there's just a lot of tasks that kind of get fall on their plates. So whether it's running now, there's a lot of grabbing the right PPE to go and enter a patient's room during the pandemic. And so there's things that have to go from one side of the hospital to the other, and you don't want to waste a nurse's time doing that. So Moxi's in hospitals today doing a lot of those fetching and delivering tasks for frontline staff.
Let's say we'll go to a hospital where Moxi is currently active. Would we run into the robot? Would we see it? Or is it working behind the scenes? What is it?
That's been a really interesting part of the journey at Diligent and bringing Moxi to life is, as a roboticist, we're thinking about the utilitarian, what's the robot doing and who's it doing it for? And so we're very focused on nurses. Like the robot is designed to be taking things from place to place so that nurses and clinicians don't have to. And so that's kind of the end users we were thinking about. And then we get out into market and we start having robots in hospitals, and we start having all of these patients and patient families interacting with the robot. Obviously, the robot's in the hallways going from place to place. And you think, when you're not somebody who works in a hospital every day, you think, oh, the patients are all in their rooms. Like the robot's not going to see patients. The patients are in their rooms. But no, the hospital's full of patients and families. And so that's been really fascinating to see what people think of robots roaming down the hall. And
I got to imagine when such a robot's moving around in the hallway and some kids are maybe visiting their parent in the hospital, that they start running after the robot, and must be some interesting interactions there.
Yeah, we had to actually add some facial expressions and things that the robot does specifically when these interactions come up. It goes into kind of a selfie mode because it will get stopped in the hall for people to take pictures. And then we've also heard from patients. You'll hear from 75-year-old grandmother who says, "Yeah, I was, my grandkids want to come visit me this weekend because they get to see a robot, and I'm like the cool grandma that has staying at a hospital with a robot."
Yeah, so as a grandparent, you can actually get to see your grandchildren more thanks to Moxi being right there. That's a really nice benefit there. Wow.
Yeah.
I was watching some movies of Moxi, and I gotta say the face really stands out. It's a robot with a very, it's not a human-like face, but it's a very expressive face. And I'm curious, what's behind all of that?
So, I mean, this has definitely been a hallmark of my vision of social robots and robots that work in human environments. I, for a long time, have thought that they have to have a face, they have to have a head, they have to have eyes. And if you look back at some of the robots that I've built, or even back when I was in Cynthia Brazil's lab at MIT, the robots that we had there that have like these really complicated faces. It's the journey that I've been on in terms of like robots that have faces is kind of an interesting one, because the robot that I worked on in grad school was this very creature like looking robot that had 30 degrees of freedom. So a degree of freedom means a motor. And so it had 30 motors just in the face that were like making all of these facial expressions. It was like pushing some of the skin on the robot's face to go in different facial expressions. So super complicated. And so then when I moved on from grad school and I was starting my first lab and building my first robot and thinking about, well, I want it to have a face, I want it to have a head. So much of what we think about is like how the robot should engage with people socially with a head. But then we were thinking, do I really need 30 motors? Like if I'm redesigning this, like how can I reduce any of this complexity? So then with all the robots that I built at Georgia Tech and UT Austin, we still had quite a few degrees of freedom or motors in the head with eyes and eyeballs and ears. And but then finally, when thinking about taking a robot like this to market, you're really thinking like, okay, how do we get the most across with like the simplest form or simplest, least number of motors? It became clear that really the thing that is most useful in that social interaction of a robot navigating a hallway and moving around people is that ability to, pan and look around and provide some kind of a facial expression. So we had this nice combination of the head moving around, but then having a digital display of facial expression. So it's been a fun journey to kind of look at what's really needed in that space.
So this robot, since it interacts with people, I'm kind of curious, what are some of the most maybe surprising interactions you've observed with humans, running on into the robot and what they do?
That's a great question. So, there's a lot of jumping in front of the robot. Is it going to run into me? And it never does. We have not had any robot run into a person, but there's lots of like fun testing behaviors. Like, it's new for people. They've never seen, you don't see robots out in your daily life usually. And so that's really fun for people to kind of have a chance to interact. And then they're usually, so the robot doesn't speak English. Moxi won't say things unless you're in an elevator. Then Moxi will let you know what floor it's going to. But so usually people are trying to talk to the robot like you do your Alexa or your Google Home, and that's kind of their first instinct. But then all that Moxi will do is kind of meep back at them, and so then they get into this like fun like talking and meeping interaction. So it's a lot of personification. It's fun.
I think it's very interesting what you mentioned there, that we don't really have robots in our lives. When we look around, I don't think, probably nobody listening right now would have too many robots in their home. Maybe a vacuum cleaner robot, but at the same time, we've been promised them for a very long time. All sci-fi tells us we're going to have robots helping us at home. And can you say maybe a little bit why it's so hard to give us all a robot in our home, and why then maybe in a hospital they can already help, but not so much yet in our houses?
Yeah. So it's so true. We've been talking and thinking about robots in movies and books, and we all feel like they should be here by now. I think that we're making our way, and if you think about the environments that robots have worked really well in, it's very structured environments like warehouses or manufacturing, where the robot can just do the exact same thing in a dumb way, almost just kind of the same weld happens every day all day long. But in order for robots to really get into people's homes and really be helpful, they have to be able to operate in a completely unstructured environment. If I think about my kid's bedroom, it's nothing like that manufacturing plant. Nothing is the same every day. So the robot has to be able to go into my kid's bedroom and deal with a completely different scenario every single day. And so that's really the gap, is we're going from robots that can deal with the exact same scenario the same way every single time, to robots that can deal with a completely different scenario every single time you walk in the door. And hospitals are one of these environments that I like to call a semi-structured environment, or it's like somewhere in between. Like if you go into a hospital that you're in a new city and you walk into a hospital and somebody blindfolded you and just said, guess where you are? And you look around, you're going to see some things and be like, this feels like a hospital. I see some things that, the hallways look you're like, they all kind of, you can't quite put your finger on it, but you're in a hospital. And the same is true for like a hotel, a restaurant, a coffee shop. So all these places that somebody could blindfold you and you could probably guess where you are when they bring you into this new city, new place. Those are all the first places that we're going to see robots, because those are the places that there's like some amount of structure for those robots to latch onto.
So as I'm thinking about robots and what you just said, I mean, there's the robot body and there's the robot brain. And is it fair to say that it's really the brain, the AI part, that is holding it back, and that maybe you are seeing some ways of making it work in hospitals now, but not yet in homes?
I think so. Yeah. So there's, because so much about, I guess I'm biased because I come to robots from a software background. And so maybe if I was more of a mechanical engineer by background, I would think everything was a hardware problem. But I do think that a huge way that a robot can have a leg up in an environment is to very, very accurately perceive the current situation and then very quickly be able to adapt its skills. So both of those are like a perception problem and then a machine learning problem. And so I do think that that's kind of this software solution to start to bring robots to these semi-structured spaces.
So if I go back to Moxi, what exactly is Moxi doing in the hospital right now?
And we can just show a little demo of what Moxi does. And what you see is here's a frontline staff member who can call the robot over, and then robot autonomously goes from one point to another, autonomously comes to where that person is. Then they can use their badge to swipe and open up one of the locked containers. And that we learned is really important, because a lot of what people need to send from place to place, they're really wanting to make sure that they know that it got to the right person. And so the fact that you have to kind of swipe your badge and really kind of log in to the robot was an important thing that we learned. So then you send it off, and here's one of the hallmark things that Moxi does is really make use of an arm to increase autonomy. So you see the robot, pushing buttons on to open doors, or swiping a badge to open a door. Mm-hmm. And then this is showing a little bit under the hood. You see the robots using the laser and camera at the base to build a map of the environment. And that's how the robot knows where it is, and that's how it can plan where to go. And then we have, it builds up a kind of semantic understanding of what all of the different locations are and what are some of the kind of manipulations and perceptions that it can expect in different places. And then, gets to its location and drops off its delivery. So yeah, that's really what people are using Moxi for every single day. It works 22 hours a day. So we like to say that Moxi works 22/7. So
what does that mean? That's a funny number, 22. Say more.
So Moxi has to take a deep charge on the battery has to do a deep charge for 2 hours a day. So we let the staff in the hospital decide like whether that's going to be from like 1 to 3 in the morning, and then it's working the rest of the time.
No.
But it finds its charger like a Roomba and charges for 2 hours a day.
Wow, that's amazing. Now, one thing you said there, it uses a laser to help it navigate. What does that mean? I mean, a lot of people probably have heard of laser pointers to point at things, but how does a robot use a laser to navigate?
Yeah, so it uses the laser to shoot out and measure the distance that it is from really everything. So when you point a laser pointer at a wall, that laser pointer stops and you see the dot on the wall. And if that wall was further away, then that laser would go all the way to the dot further away. And so the sensor on the laser sensor on the robot is able to sense how far away that wall is. And so the walls then it takes a lot of measurements, a lot of times a second, and is able to build up a model of exactly where all the obstacles and walls are in the building.
This is so fascinating. And when I look at the video we just watched, I can't help but be kind of reminded of some of the things I'm involved in myself, of course, with Covariant, where we look at robotics for warehouses. And it's almost like the robot is treating the hospital as a warehouse where it's bringing things from one place to another. Is that a reasonable way to think of it? Or
yeah, I mean, we are doing a lot of materials management and logistics tasks, and really hospitals have a lot of challenges with. There's just a lot of things that have to go from place to place because as a patient in a hospital, you need to have lab work done. You need to get things from pharmacy. You need a new bandage every day. And all of those things that you need as a patient are coming from different places in the hospital, and they're usually pretty far away. And they have processes in place to get things to the nursing unit, like a once a day delivery from pharmacy or a once a day delivery from supply chain. But in the course of a day, there's just a lot of things that aren't normally stocked on a nursing unit that somebody has to go run and get.
And then, of course, it has the additional challenge that unlike a typical warehouse, there's a lot of people to interact with along. Because I don't think any warehouse robots that I've seen have such a cute face. Moxi looks at you; it's totally different. It's amazing.
Yeah, we definitely wanted to. I mean, that's I think one of the things we liked about the challenge of putting a robot in a hospital environment as opposed to a more industrial setting is that you have to solve that problem of being around people and you have to get that right, or the robot's just going to be in the way, and it's not going to be helpful. Like the only way the robot can be helpful is to kind of seamlessly fit into the flow of what's going on.
Right. And so in a lot of your work, and I don't know if that's the case for Moxi, I'm curious, your robots learn. They learn from interaction with humans. Has Moxi been doing any learning at all?
So Moxi does learn about some of the different tasks and things that need to be done in the hospital from demonstrations. Currently, those demonstrations happen in an onboarding process that our staff is very involved. Eventually one day our vision is that end users like nurses and clinicians could be kind of teaching and reteaching Moxi what to do.
But am I understanding this correctly then, that if a hospital gets a Moxi robot, this hospital could be quite different from other hospitals that already have one and have different things Moxi needs to do. And then there is a session where you can teach Moxi what you need in your own hospital?
Yeah, exactly. And so, it's kind of like we were talking about that, every hospital has a lab or a place where they keep all the supplies, but just because you know how to navigate one hospital location, you don't know how to do that task in another place. And so we do have an onboarding session where you take Moxi on a tour of here's all the work you're going to do.
And is Moxi truly autonomous, or is there somebody behind the scenes who is actually steering it at times?
So it's an autonomous robot, but we do have the ability to remotely supervise. And if needed, most of the time it's autonomous, but then you have the ability to, you can remotely supervise and decide to, pause the robot for any reason or, intervene.
One thing I'm curious about is, what if there's multiple robots in the same place? Do they interact at all? How does that work?
So they interact in that they're all the fleet of robots is responding to the same kind of schedule of tasks, but there's not any kind of robot to robot handoffs at this point.
Got it. But they're splitting the work in some clever way.
Yeah, exactly.
Now, one very specific question: what if somebody wanted to see Moxi? You wanted to just where did they go? What hospital did they go to if they want to have some hopes at running across Moxi?
It's funny. Yeah. It's unlike some products where you can like go to a, shopping mall that has some cleaning robot, like, especially today, hospitals are really hard to get into, so even if, you have to get a special visitor badge and get back into the places. But yeah, we're in and around, our deployments are all in Texas right now, but this year we're going to be expanding outside of Texas. But yeah, so you could, go to some hospitals in Dallas and Austin and work your way in and see a Moxi.
Sick, go to Texas so you can be in a place with Moxi.
That's right.
How many Moxis are there right now?
So that's not really something we share publicly at the moment, but we're in the early stage of a growth.
Are you able to share a specific hospital though where there are Moxis if somebody were actually curious to encounter one?
Yeah, so we're one of our public partners is HCA North Texas in Dallas. So they have a division called Medical City Healthcare.
Mm-hmm. So that's, you want to see Moxi, that's where you can go today.
Medical City Healthcare.
might have a hard time getting in, but if you make it in, you can see Moxi delivering things. It's really cool. Now, Moxi is deployed in hospitals, but that's amazing. But there must also have been a time when you didn't know yet you're gonna put your work into hospitals.
Yeah.
You've been working for a long time on robots that can be effective around humans, and then at some point you decided, yes, I'm gonna build a robot for a hospital. How did that come about, and why?
Yeah. It was a journey, but I actually got some funding from the National Science Foundation. Because a lot of my research over the years has been funded by the National Science Foundation into kind of the, fundamental research in human robot interaction and machine learning. And so we got a grant to really think about like, well, what would the commercial applications of the kind of things we've been doing be? And so then, we really that National Science Foundation grant started exploring, what are some of the places that are that middle ground of there's some structure for a robot to take advantage of, but so it's not a completely open-ended task, but it's more dynamic than a warehouse or
Right.
and so, we thought about, kind of a lot of the ones I listed off, like restaurants, coffee shops, gyms, healthcare. And as soon as we started exploring hospitals,
Mhm.
it became really clear that this is an area that there's a true need. There are challenges and logistical tasks that really high valued nurses are doing, and so that was the real motivation for us, is when we found how hard nurses and frontline staff are working, and feeling like, oh, these are some things that we can really do, we can really help. And
Mhm.
so then it kind of went from there.
How do you build up the trust? And the first time you bring a robot into a hospital, how do you make sure people actually want it?
Yeah, we let that be really organic. We kind of we usually have a set of staff that are the champions that have really been involved with, like, thinking about, like I said, that tour that Moxi's going on, like, this is the work you're going to do. And then from there, you have a couple of nurses that start using it, and then they start telling you, "Oh, why are you going to run down there? Like, didn't you know Moxi could do that?" And it just sort of
Oh,
builds from there. And so if we track like a new installation, you can kind of see, like, the first week you might get 20 deliveries, and then it just sort of grows and grows and grows until it's like 100 deliveries a day or something.
that's so interesting. You don't even set it up to do specific things. You just let the nurses and staff decide whenever they want to call upon Moxie, and it just takes off.
Yeah.
Wow.
Yeah. And so, I mean, we start with, we usually come in with a good idea. Often from a previous site, we can say, like, well, usually people like to send Moxi around to do these kinds of delivery tasks. And so that kind of gets them started. But then, invariably, like, every site, even, there'll be new ideas, like, well, could we send not Moxi to get that contrast liquid from radiology? And it's like, yeah.
Now, you have Moxie doing a lot of helpful chores right now, but I gotta imagine that even though Moxie is already super helpful now, that you have a bigger vision for many more things you would see it do in the future. Can you share a little bit about that?
So, we don't share a whole lot about the roadmap precisely, but I think what I can say is that we're really excited about being, one of the first companies that really putting manipulation on a robot that's so close to people.
Mhm.
And so I think, we are kind of rolling out that roadmap of manipulation very slowly, because it's so new to be doing it so close to people. But that's really where we want to be, peeling more and more complexity, and putting more and more autonomy into the tasks that the manipulation tasks that Moxie's doing.
As you think even broader, maybe beyond what you plan to do yourself, what do you see as some of the high impact things of robotics in healthcare that we could expect maybe in the next 5 years or 10 years?
I mean, I think the pandemic right now is really getting everyone to ask this exact question. It's like, what are the ways that we could be delivering better healthcare and as a society? And what are the ways that technology can really play a part in that? So I think, some of the things that we're seeing were kind of just taking off, and now they're really, being put into use, is things like telemedicine. And so I think that is a place where today that's a very manual process, where somebody wheels in an iPad for somebody to interact with. But those telemedicine robot, remote telepresence robots, I think, are going to really take off in healthcare. Um, they were kind of held back because of like information security and privacy. And I think that's always kind of, made it hard for telepresence robots to not just be like thrown around everywhere in healthcare. But I think what people have realized is that, those are just software problems. Like we can solve all those security and software problems, and then you can deliver a lot of care to everybody. So that's a space that I'm not in, but I see taking off. It's really, really interesting. Let's see. Another is, I think in the same way that we're starting to see lots of voice interfaces and devices in our homes, and everybody's getting used to that. I think we're going to start to see more of that entering healthcare. You go to your doctor's office, and a lot of times they're spending so much time just like typing with you sitting there. And so it drives me crazy. It's like, so, and I know that like doctors and nurses, like everybody that has to do all of that documentation hates it too. So that's a big thing that I think AI and, not necessarily robotics, but AI and voice recognition and all of that technology is really going to play a huge part.
Yeah, I like those. And for the first one, telerobotics, if you think about it, telemedicine, I mean, it's kind of crazy to think that if you're sick, you go to a place where a lot of other
people are sick.
You hang out near them to then finally get the doctor, as very often, a call and maybe a local robot that could help a little bit with some basic, physical aspects could take care of it and be a lot safer. Not to mention how to even get to the doctor's office if you're sick and you don't have anybody who's right there to get you there. It seems really good way to go.
Absolutely. And, I think until the pandemic, the biggest driver of telemedicine was like rural locations. So if you don't live very close to a big hospital, it's hard for you to get to an expert in some condition you have. So that was really the biggest driver of telemedicine. But now I think everybody's seeing that, really, I don't want to be going to the hospital if I don't have to. I don't want to go to the doctor's office if I don't have to. Let's put this virtual step as the first step.
So Moxi is active in hospitals. And of course, now the past year has been very, very different. COVID-19 is changing everybody's lives, but I would imagine even more changing lives in hospitals. Curious, what have you seen and how has it affected the role of Moxi?
So it's changed everything. And it's been incredible that we have been really had this front row seat to watch how amazing healthcare workers and hospitals and especially the frontline nurses have been the real heroes of this pandemic. And what we've seen is that just logistically from what Moxi is doing, we had a moment like right when the pandemic hit that we're a startup, we can pivot on a dime if there's something else that they needed. So we were reaching out to all of our customers and saying like, do you need something else? Like, do you want us to put a UV light on the robot? You want us to do something else? Is there something better that Moxi could be doing to help you? And what we kept hearing time and again was, no, actually, we just need to deliver 3 times as much PPE around the hospital. That's exactly what we need Moxi to be doing. And the other thing that we learned was, so a lot of hospitals and, over this past year and still are completely changing the layout and where patients are, because of isolation. So you want to take and we're going to change this whole wing to be a COVID wing. And then once the cases go down, you're going to take that wing and now this wing can be used again for non-COVID patients. So a lot of that like change has been happening. And so that's been really interesting to see just from a robotics and deployment perspective, like, having a robot that is adaptable and able to kind of change its exactly how it's working has been really, really important to be able to help these hospitals kind of adapt and be resilient to all of the different changes. And I think, the bigger thing is we've just been humbled to be able to be part of the small part of the help that we can provide to nurses. It's been incredible to see.
Really nice that you're able to help that way. And also the fact that it's a robot, it seems has another benefit, which is maybe people can space out more and Moxi can bring things to people, not just from.
Yeah, I mean, that's part of the benefit is really, the hospital leaders are excited to say, look, we don't have as many people moving between different spaces in the hospital. So that's inherently safer. Another example is just, COVID test samples. So like if you go into the ER of a hospital, one of the very first things they do is give you a COVID test. And those tests have to be carried to the lab by hand by somebody. And so they've been able to have Moxi do that instead. And then you don't have a person that's handling that sample. You can just load it into, give it to Moxi and take it to the lab. So there's these safety things that we've been able to find and be a really benefit to the staff as well.
Yeah, that's amazing how that occurred to me. But the way people run around hospital, crossing so many other people's paths, and Moxi can take away a lot of that distance covered and a lot of crossing. That's amazing.
Exactly.
Yeah. Wow. Some of these things that you just described seem very feasible today, right? Speech recognition seems to work. Automatically making notes. I mean, sure, there are some challenges, but it seems like it should be feasible. What are some things that you think are still very hard and where we will need some new breakthroughs, but that you hope we can get to in the kind of AI robotics healthcare space?
Yeah. So I think that if we could, I think the holy grail for healthcare and robotics in healthcare is really helping people in their homes. Is that, if it's elder care or if it's helping somebody who's recovering from a surgery, like there's so much help that people need. And so much of it is, just kind of logistical help. Like, you're recovering from a surgery, you can't walk around your house. You just need, help bringing things from point A to point B. Or if you're, an older adult, if you're aging at home and you can't fully take care of yourself, just the activities of daily living, these are the things that I dream of, robots and AI being able to help out with one day. And, we have to tackle all of those hard problems about, being able to send a robot into, your house. I've never seen your house. How do I program a robot to do anything in your house when I don't know what your house looks like?
We are dropping new interviews every week, so subscribe to The Robot Brains on whichever platform you listen to your podcasts. I was reading one of your papers on reinforcement learning with inaccurate feedback. Reinforcement learning is, of course, where a robot learns from its trial and error from feedback. But you're specifically investigating inaccurate feedback. Can you say a bit more about why that matters and the context there?
Yeah. So, reinforcement learning, I think, is a really interesting area because people think of it as one of the branches of machine learning that is, most similar to, and it has a lot of similarities, or people you can easily conceptualize how animals or people learn that way. Like you try something, it worked or it didn't work out, I'm going to try it again a different way. So I think there's something really appealing about that for reinforcement learning. And so for me, I'm interested in how people are going to interact with robots that are learning. And so for me, reinforcement learning was always an interesting paradigm because if it's a machine learning algorithm that people can easily conceptualize, then people are going to be able to interact with that machine learning algorithm and give it the right feedback or give it the right demonstrations, because then they can kind of conceptualize what the robot's going to do with that. But then anytime you add people to an algorithm or a robot or a process, that's never going to be exactly perfect, right? People are going to make mistakes, or they're going to tell the robot, you're trying to teach the robot to, fry an egg, and you accidentally give bad feedback when it did the right thing, or you give good feedback when it did the wrong thing. And so that can be really confusing for the robot, because it's expecting that it's getting the right feedback. And then it's like, oh, I'm not supposed to do that. Okay, I'll never do that again. And so that's kind of that's the reason that my student Taylor Kelser-Fleckner was interested in exploring that area of like, well, what do we even do when you have an inaccurate person? And what are some of the reasons that people might give inaccurate feedback?
Reminds me of sometimes you have students in class who are clever enough to question you as you as a professor, and of course everybody gets something wrong every now and then, and some students actually will call you out on it, and it sounds like you're helping teach robots the same skill to call it out somehow, or understand.
Question authority. The places where this is really necessary is and the one that I think is going to come up with robotics a lot is if you think about the way that a robot moves around, and if the robot has an arm and it has 6 degrees of freedom, that arm can move around in a particular way, but it's not going to move around in the same way that my arm moves. And so if I'm giving feedback to that robot about whether it should move its elbow up or down, like I may have a idea about how the robot should move, but it might be based on how my arm moves. And so if I'm telling the robot to move its elbow up, but really the best way for the robot to do it is to go down and around or something, those are the kind of inaccuracies that the person might have about the robot that would cause them to give bad feedback. So it's kind of interesting. And once you know that, and that was kind of the crux of Taylor's work, is like, once you figure out the kind of parts of the state space or the parts of the robot's motion space that the person gives inaccurate feedback, then you can kind of say like, oh, the person always tells me to go, that it's bad to put my elbow up. It's actually good. And you can kind of flip that feedback, and you're like, oh, I know Peter's telling me this is bad, but I know it's good. And so I'm just gonna do the right thing.
I mean, ultimately we want robots to solve problems that we as humans cannot solve, right?
Exactly.
And then not going to be perfect. We're going to just have some hunches, but the robot should ideally take it to the next level.
Yeah, absolutely.
Now, talk about interacting with robots. Back when I was a student at Stanford, there was a stare robot, which was the robot that was supposed to kind of be around in the office, the university, and fetch things. And I was just catching up with Olga Rysakovsky last week, and she's now a professor at Princeton, and we were talking about that robot, and she said, that robot was very cool in many ways, but it turns out that when she asked the robot to go fetch a mug, the robot would not react at all. Whereas if anybody else asked, the robot would react and go get the coffee mug. And ultimately it came down to her, being a woman, having a very different voice from everybody else in the lab who had a male voice. And so I'm kind of curious, in your experience, as you build robots to interact with people, like what are some similar things you might have run into or that you need to be really careful about?
Yeah. Let's see. I mean, voice is a really good one. I had the same exact experience as a grad student. I had to train my own voice models for for all of the robots that I interacted with in the lab. Because we used back in the day the Nuance platform for speech recognition, and it came with its like default model. But if you wanted it to be better, you could train your own voice model. And so I remember I always had to do that. So voice, and expecting there to be a broader range of pitch, and but also one of the things we've thought about even with Moxi is height. Like the average height of women and men, and what height should Moxi be at in order to not be too tall and assuming, especially since, a large, part of the population that our end users are predominantly women in nursing. So I think that was an interesting one that I hadn't ever thought about in the academic and research setting. And sometimes I think we always look at whether there are gender differences in like the ways that people are providing feedback to a robot learner, some of this, reinforcement learning feedback. In my work, we've never found like strong gender differences, but it hasn't been something that we've, really deeply explored. But I think I think that there, just the way that people teach and the kind of way that people give feedback is likely to have some gender differences as well.
Another thing I'm wondering about, which must come up in hospitals in interactions, is I imagine the robot is sometimes, the robot might not be the one delivering bad news or good news, but there's a lot of bad and good news going around in hospitals, and the robot is around all those emotions. Do you see the robot playing any role in that in the future?
Yeah. So, I mean, it is a real opportunity, I think, to be an empathetic partner in this environment. What we've seen right now is that, Moxi is very new. Right now, it's a very novel and new thing that people see in the hospital kind of for the first time. And so it does bring this moment of levity, and you might be dealing with a really hard situation, but then you get like this little distraction and little thought about the future and a little bit of excitement. And so that, I think, has been one piece that we've seen that's been really nice. Even for the nursing staff that interact with Moxi every day, we'll get comments sometimes around, wow, I had a really hard day. It's great that Moxi's always smiling. It's like that kind of, it's good it's good to have Moxi's like hard eyes around on such a hard day. So I think there is this opportunity that, even though it's a really stressful and sometimes difficult environment, that, we're all still humans, and we do want to kind of disconnect and have some levity.
Going back to the company as a whole, Diligent Robotics, which is a company behind Moxi, and you're the co-founder, CEO of Diligent Robotics. Kind of curious from an entrepreneur's point of view, when you've always been working on making robots, tech towards robots that can help out and help humans, but when did you just say, hey, it's time to build a company? How did that go?
How did that go? It's a great question. Honestly, it felt like there was a distinct change so robotics in general is, in my view, it's a lot of different things coming together. It's a big system. You have to have the right kinds of cameras, and you have to have the right kinds of motors, and you have to have the right kinds of software that lets the robot map with a laser, and you have to have the right kind of software that lets the arm move. And a lot of these pieces have been making advances over the last 10 years or so, such that so many of the pieces are becoming so much more reliable to be used every day and not break and not have to be restarted. And so that's, I think, what we started noticing, is that there was an opportunity to really do the engineering work to take things that work pretty well in the research lab and get it to be this robust and reliable product. And so I think it was, the advances that I kind of saw over in both perception and actuator motors getting much cheaper, and perception getting, cameras getting much cheaper and better, that at least got the wheels turning, and then the rest is history. It was a slow kind of probably 2-year process of thinking about starting a company and then finally doing it.
What do you think was the trigger? Was it talking with your ultimate co-founders? What made it actually happen, you think?
So we just kept taking the next step. We just kept saying, well, this still feels like a good idea. What's the next thing we would do? And so it went from like a brainstorm session to, well, this still feels like a good idea. What's the next thing we do? Well, let's get some like tiny bit of money from the National Science Foundation. And then it's like, well, this feels like a good idea. What's the next thing? Well, let's get a bigger amount of money from the National Science Foundation. And that ended up being like this SBIR grant that led us, which is, the way the National Science Foundation funds like early stage companies. So we actually formed the company and got this research grant. And that one, we actually put robots into hospitals for the first time. And it was great collaboration with UT Austin as well, because they let me take they let us rent essentially the equipment in my lab and borrow it for a day or a week at a time. And so we would take these robots from my lab at UT Austin and we would put them in a hospital here in Austin with some really innovative nurse leaders who somehow convinced their CEOs that it was fine to let these women with this robot come and see what nurses think. But from that, we had all of this great information from nurses about like what do they spend their time doing, what do they think that robots would do, and we also had feasibility demonstrations at the end of that day or week that we were there. We'd take some video of the robot going into a supply closet and doing something, and coming out and dropping something off, and that was what really, that feasibility, and when we saw the robots actually, we're here in a hospital, the robot is doing things that we've only ever done in the lab and it's working here, we can do this. And so that's when we really kind of got the conviction to go out and raise capital. We found some amazing partners in True Ventures who believed in us. And from that, I had this camera from my phone in the hospital, like the best demonstration that we ever had in the hospital. I just whipped out my phone really quick. I'm like, oh my gosh, that's happening. And it was this terrible video because I'm shaking because I'm so excited. I'm not really looking. And so I had this terrible shaky webcam video that we went around and talked to investors, and they believed in our vision.
I think it makes sense because it's rare to see a robot do something in the real world, and there you are, and you already had it working. By the time you knocked at their door, you already had a robot that was already actually functional.
Yeah, and of course, it was all duct tape and glue and the software side, so we had a lot of work to do to make it actually robust and reliable every day. But the for me, that was the point where I was like, oh, it's ready. We can make this happen.
Then once you take that money, there's kind of no turning back.
There's no turning back. The wheels are in motion.
But as I understand it, you're all in, but at the same time, you are actually juggling a lot of things. If I understand correctly, you are founder, CEO of Diligent. At the same time, you're still professor at UT Austin, and I checked your Google Scholar. You're publishing at a very high rate. Yeah.
That's right. I have some amazing postdocs and students.
So yeah, that's a lot going on. Wow.
I will say that, I also have an amazing professor husband who is a true 50-50 partner in this journey.
Which is still rare, unfortunately, and glad you're in that situation. That's really nice to hear. So as you think about Diligent as the company, and as you went through your journey, and you think about maybe other robotics entrepreneurs or budding robotics entrepreneurs, are there any lessons from your journey so far that might be good to share?
I think the story I just told about like really proving out the hardware, doing as much as you can to prove out the direction that you want to go before you start that funded journey that then has a very specific timeline. Like, I think the fact that we took a while, we took like 2.5 years to really say, okay, now it's time to like take funding and really go. Because after you start down a path, it becomes harder to, and especially with robotics, every change that you want to make to the robot is, it takes a long time to order parts and pieces and change anything about what you're doing. So everything you can do to get conviction and certainty around your idea. I think the other piece of advice is to focus on a whole solution, like you want to think about a customer and a problem that they have and the end to end, like the whole solution that you're going to provide, because people don't know what to do with robots. They need your help. Like, as a company, you have to provide that whole solution. Like, you can't just say, I'm going to deliver you a robot and it's going to be awesome, and you're going to have to figure out how to work it into your company and in your hospital or in your restaurant. Like, at this point, with these first companies, these first service robot companies, you're seeing, a lot of the companies that are being successful are providing that like whole end-to-end solution for a customer. Whether it's security robots and you're providing that end-to-end solution, or hospital robots and you're providing that end-to-end solution, or cleaning robots, and so thinking about the customer's whole journey, I think, is really eye-opening. If you're used to only thinking about robots, and then you have to start thinking about like the whole environment that the robot lives in. It's interesting, and it's a big part of the problem.
Yeah, I will say it's my experience too, is that customer doesn't really care whether it's a robot or not. They just want help.
Yeah. Sure. And if it feels too hard, to do it with a robot, they'll find another way to fix the problem, right? So,
yeah, it's very interesting. And as you think about kind of growing the team, and any thoughts on that as you've been growing the team at Diligent? Any advice?
I mean, it's super important. We spend so much time on hiring, and every hire I meet everybody, for every engineering hire, we would have people come to Austin, go out to dinner, make sure that it's going to be, somebody it's really going to be a good fit for the team. And I think, we've had a big focus on diversity of ideas and backgrounds, and just every dimension of diversity is something that we really focus on. And it's hard. It's funny because like Vivian and I, my co-founder is Vivian Chu. So we started the company as two women, and we always joked in the early days, like, oh, we have a diversity problem. We got to go find some guys to get to work with us around here. But it becomes like, once you start growing the company, it becomes very easy to get, we just have to move fast and hire as many people as possible, hire the best people possible, hire anybody we can find. And it becomes, if you don't make diversity something that you're thinking about, and you really make sure to like say, oh, well, let's make sure that we're actually interviewing a diverse set of candidates. We found that it's like, even as two women, we have to make diversity an active part of our hiring process. So
sounds like you're succeeding at it. And can you maybe describe some of the kind of positive consequences you're seeing in that?
Oh, so one thing that I think is nice about we have a very diverse team, and the mutual respect that you see, and there's we have this yes and culture, where it's like, somebody, you can disagree with people, and there's not just one way to do things, is what you get out of a diverse set of people, is you get a diverse set of ideas, and then you get the respect that comes from people hearing, multiple perspectives. And so that just becomes kind of ingrained in the culture, and it's really nice. And I think, then you have the opportunity for more good ideas to come to the forefront. And it's fun because, one of the best examples that Vivian always points to is that we had somebody on the team that didn't have a robotics background, and strong software background, and they they came, and one of the first things they did was like comment on like the structure of the robotics code base, and they're like, well, why would you do it that way? And then the robotics people are like, well, because you always do it that way. And it's nice to sit back and be like, well, why do we do it that way? That's a good idea, we should think about it. And so that idea that maybe there's a better way is it's just easier to come about if you have a really diverse group.
One thing I'm curious about, and I really don't know much about it at all, even when I was trying to research things for our conversation here, is your background. As I was researching, I could find PhD at MIT, but I couldn't find much before that. What happened before that? What led you to then be a robotics PhD student at MIT and then to where you are now?
Yeah. So let's see. I grew up in I grew up in a few different places. My dad is in the oil industry, so we kind of moved around a little bit. But then we ended up, once he landed a job in Houston, big oil city, we didn't have to move anymore. And so I grew up in Houston, and I was pretty normal. I was always into math and science. And so I knew I wanted to go into engineering, and that's about it. Like, I didn't really know what I wanted to do. Definitely, I was not in any robotics clubs or coding clubs or any of that. So I always tell people that are asking me, like, what should I have my elementary kids do to end up to, I'm like, they don't have to do anything. I didn't start doing any of that until grad school. It's like, you can definitely, come at it from a lot of different ways. What else? So, I mean, I was captain of my dance team in high school. Like, that's like, I was definitely, I had a very kind of diverse childhood background.
Gotta imagine what you just described. In fact, that you get many of those questions. Like, a lot of parents, I mean, you're a parent, so a lot of your friend parents probably ask you, how can my daughter
like, what robotics club should I? My fourth grader had a flyer come home about like an AI class for fourth graders.
Oh, wow.
And I was like, I'm looking at this, I'm like, we haven't done calculus yet. How are we going to do? I don't know. So,
be the teacher and you didn't know it yet?
Yeah. So yeah, I think people get it. They really want to set their kids up for success, and I get that. And I, obviously I want to also, but my advice is always focus on the fundamentals. Let's work on multiplication. Get really good at that.
Yeah, I mean, the foundations keep coming back and back. If you look at the most advanced things today in AI, actually, if anything, are relatively simple compared to some other research domains in terms of what you need to do. It's very foundational. It's not something that takes necessarily hundreds of years of expertise to build up, right? It's
absolutely,
but the foundation is really important.
Yeah, probability. It takes people a really long time to get probability.
Gotta imagine, though, that even though you might not have been in robotics clubs and so forth, maybe there was still something else going on. I don't know. Like, it sounds like you're always very curious and looking to learn more. You think that's the secret? And how do you think people might instill that in their kids?
I think the other way that I see it is like, if I have to draw a line towards everything I've done in my career, it's like really opportunistic too. It's like, seeing something, be like, oh, that could be interesting, and then like go for it. So like not feeling like, well, I decided I was going to be this. So like one example for me is I went to like I knew I wanted to do engineering, but I didn't know what kind of engineering. And then, I started doing electrical and computer engineering at UT Austin, and I, got a job during college, like in the summers and every once in a while in the semester at IBM, a big company here in Austin, and I was part of the like chip design group at IBM, and we were writing software to like test that chips were being built the right way. And that was really fun because I got to learn how to program. Like that was really how I learned how to program. We did a ton of C++ code. And that was that was really the first time I coded, was like learning on the job at IBM. And so then here I was an electrical engineer. I was like, oh, but I actually really like coding. Like, I think that's what I'm going to do. And so, not being, stuck in what you said you were going to do, but like open to like, oh, well, I like this better. This is fun. This is good. But then I realized I didn't want to build chips anymore. I wanted to work on something a little higher up on the computer.
There's a lot you can do there, though. And then you specifically chose to go after how robots interact with humans. Where do you think that specific interest came from?
Yeah, that was interesting because I was there as a college student at IBM, writing a ton of simulation software for chips, and trying to. The best part about that job, just for a tiny tangent, is that you get to come in and be like this junior engineer, and you're doing this like test code for the like senior engineers that are writing this, like, they've been writing this, like it was BLSI to program chips. And, if you find a bug, you get to go to this like really senior engineer and you're like, I'm sorry, sir, that I found a bug in your code. And they're like, no, you didn't. And so you have to like document it like so hard. But I still remember to this day, like I one time I found a bug in like this like really top guy that he never had any bugs in his code, but I ran the test that I got to go to the one and be the one that found it. But so that I realized at some point in that job that it wasn't like going to be my career. And you're in college and you're like, what do I do next? And so I thought grad school. So I should go to grad school and kind of think about what I want to do with this foundation. I know I'm interested in computer software and programming. And then I started just reading a lot of books, and I had two books that led me to decide that the MIT Media Lab was where I wanted to be. I read a book by Don Norman called Things That Make Us Smart, which is still one of my favorite books. And it is all about, it's really all about like design and human computer interaction, but it's really about just the design of things and how you can make a door handle that people know how to interact with, or you can make a door handle that's confusing and people are there like, how do I interact with this thing? And so that book was the first time I really thought about design and form and function and what can be communicated through design. And I found that fascinating. And then I read the book Affective Computing by Roz Picard. And that was all about how you could make computers understand emotions, and that people's emotions in the end were signals. And Roz's background was signal processing and electrical engineering, and here I was like just coming out of this electrical engineering degree. I'm like, this is the coolest electrical engineering person I've ever met, like somebody who's like taking emotions as a signal processing problem. So like those two things really made me say, like, there's something here around building machines that are going to be easy to interact with. And I thought, if I want to build machines that have this like Don Norman, like form versus function. And so then that led me to the Media Lab, where it's like the mecca of building machines that are easy to interact with. And then the rest is history. I ran into Cynthia Brazil and I saw her social robots, and I was like, I'm done. This is it. This is what I'm doing.
Yeah, here you are, bringing them into the real world in hospitals, which, I mean, must have been a dream as a PhD student. It's
exactly. Happening. It's kind of hard. It's kind of crazy.
Andrea, this has been just absolutely amazing conversation. So thankful to have you on. Thanks so much for joining us. Yeah,
absolutely. It's been really fun. And yeah, thanks for having me.
Yeah, I'm wishing you all the best with Diligent, Moxi, and your efforts as a professor and at home as a parent. And hopefully we can cross paths again in real life soonish.
I know, one day soon.
Thank you so much.
All right, thanks.